Welcome everyone to the Dallas Personal Robotics Group Robot Builders Night Virtual for June 18th. It
Uh-oh.
Uh-oh.
I think we lost him.
is about, and
I think you had a Starlink dropout there, Paul.
oh, yeah, that might happen. I'm on Starlink, so I might need someone who's on a reliable connection because I've just so you know, Starlink is sitting on top of the trailer, and that big old pine tree there is sitting between it and the satellites, and so I do expect the occasional dropout. So
Do you have
Nelson,
Elon's number? No. Okay.
Send him an X.
yeah. Okay, so we got Nelson, Carl, John, and Doug in queue, and then we'll move to open mic. So, Nelson, how'd you find out about us? Welcome, and tell us about your robotics interest.
Yeah, so I'm a recent graduate from electrical engineering at University of North Texas, and I really enjoyed playing with a STM32 microcontroller. I thought that was very fascinating. And I've always wanted to do a robotics. I always wanted to make a robot or do something with automation. I think that's very interesting. So I was just looking around through Google and seeing, where could I find a club where I could really do this kind of thing, have a supporting team essentially to really build that foundation and kind of have like that guidance as well. But yeah, so and then this is how I found this organization as well through searching through online media essentially.
Cool, welcome. And just so you know, if you look at DPRG.org, we've got a very special presentation coming up this Saturday at 10 a.m. Central. So one of the things, the DPRG is the DFW Metroplex's only adult-focused robotics group, and personal.
Elon, help.
So Ray, you want to pick up for Paul while the trees in play, or Carl?
Maybe
Yeah,
maybe Elon is busy working on Cybertruck or something. Paul, we lost you again. But I think you were saying
Okay.
you were describing how DPRG is kind of like the only adult-focused personal robotics group that we know of in Dallas, and been around since '84, and there's an actual wealth of experience among the club members here, and ever since COVID, we've been we've attracted a lot of people from a lot of friends from the Great White North, and they've brought even more experience to us. So it's pretty awesome what you can find here, Nelson. So we're happy to answer questions, and we also are always appreciate show and tells. So and sometimes just brainstorming, and you never know what comes up. Sometimes.
Carl, do you want to mention about Saturday while you're just
I was just rambling. So this Saturday, I'll put a link in the chat. But this Saturday we have remote presentation from, I think, someone in the Seattle Robotics Society who
Bob Cook.
Paul. Okay, yeah. But yeah, and he's got an excellent routine for finding orange cones, if I understand.
Yeah, so he's actually lives in Canada, but he's the most recent winner of the Seattle Robotics Society's Robo Magellan contest, and he's talking to us about how to train an AI to recognize cones, an AI that runs on the robot. So that'll be pretty exciting. and that will be at 10 o'clock Central. And it's a virtual. The meeting details are on the website, and there'll be no in-person meeting at the DMS.
I'd just jump in and say I appreciate the need to differentiate from youth-oriented robotics, but I would resist using the term adult-themed robotics for obvious reasons.
Oh my goodness.
I said
Kareem.
adult-oriented, not adult-themed, Kareem.
Yeah, one leads to the other.
The voice
Okay.
of reason,
Okay.
Kareem.
All right.
Oh no, you don't have to go that far, Kareem. I agree with you, but just because who on this panel right here, who on this thing is actually an adult?
Good
Well,
luck.
that's another topic, but
Yeah.
all right. Nice save, Harold. But
Well,
yeah.
you know, I'm trying. I come through on occasion, so you know, what can I say?
Thank you, Harold. So, Carl, you're up next.
Oh, I'm up. Okay. So I don't have much because I've been, out of town a few weeks, and anyhow, I'm focused on a couple other things at the moment than robotics. But while I was at the vintage car convention last week, somebody mentioned flexible heat shrink. And I'm wondering if anybody knows about such things. So, you know how normally the heat shrink, at least I'm familiar with, that we've all used, I suppose, when you shrink it down, it doesn't flex very much. It's pretty stiff, pretty rigid. And what my friend described was, he said it might be hard to find, might be a little expensive, but he described something, a neoprene-based heat shrink tubing. Now I couldn't find it offhand on a quick search on my phone, although I did find there's thinner walls that's advertised as more flexible after shrunk. But has anyone heard of neoprene heat shrink tubing? Oh, look at this. Kareem, for a guy just lurking, Kareem, you've got some excellent contributions already. Look at this. Have you tried to use this stuff?
No, for flexible situations, we usually go with other forms of cord wrap, like the I can't remember exactly what it's called, but there's a form that's sort of like a weave that if you need to make it bigger, you push it together.
Huh.
But it's not.
It's just to organize chords or something.
It's just to organize. Yeah, it's just to organize chords. It's not true insulation, and it's not
This stuff.
like that stuff. It's like a
Chinese
finger trap.
Yeah, that stuff. Okay, it's like a chafing shield too.
Yeah.
Yeah.
Well, this is cool because I found some just the Amazon search. I found some watertight stuff that has adhesive on the inner surface of the tubing, and but this McMaster car link you shows has, look at this. It's got interference shielding heat shrink. It's got a layer of conductive cloth. Wow. Food industry capable splitters, heat shrink cable splitters. Look at this. Wait, we could go to town.
McMaster car is lovely.
Oh,
It's expensive too, but it's lovely.
I know that, but wow.
What's the flexible? I don't see the flexible.
Yeah,
in
that was.
It's continuous flex abrasion resistant heat shrink tubing.
Ah. Oh.
Yeah. Silicon rubber
Silicone. Yeah.
with a shrink ratio of a little less. It's 1.7 to 1. I guess the common one we see is a shrink ratio of 3, but
anytime you go really tight against the cable, I mean, there's going to be a limit to how flexible it is.
yeah, right.
Unless you already have like a silicone wire, which is
Begin with.
inherently flexible. Yeah.
You know, that's an interesting point about because there's okay, this is a bit of a detour, but when you talk about things flexing, the diameter seems to make a difference, right? And so I'm going to put another link in, which is totally not related to robotics, but one of the places we visited last week in Ohio is this guy that does carving out of ivory. And one of the things that he carves, here's the link to his museum, are ships. And for the ships, and these would be sailing ships. So he's got the history of ships from like thousands of years ago to recent times. And he makes ropes and rigging for these ships, but he makes it out of ivory. And this really, and what he does is he starts out with a bandsaw and he makes these thin strips, and then he puts them in this groove thing and he rotates them around and sands them down. And he winds up with ropes that are, I mean, really thin, and he can flex them quite a bit if you see the photos in his gallery. So anyhow, to your point, to your point, Kareem, about the smaller diameter with the inside, yeah, being more flexible. I think there's some kind of relationship to this, but anyhow, that's my non-robot distraction.
So is he still using ivory? Because I thought that was like no, you shouldn't use ivory.
Well,
Walrus tusk and stuff like that.
you can't import it. And he
Can't import it.
started off, I mean, our group actually hired the guy and they catered in his museum. He's been doing this for 47 years.
Wow.
And so he explained that, you know, the import ban started, I don't know how many decades ago, but since then, what happened is that there's all these old timers that brought stuff into the country before the import ban. And it used to be that they'd find a place to sell it, but then lately they just want to donate to him. So he just gets all this ivory donated for free. And he cranks out about 2 of these ships a year on average, he said. The simpler ones take 4 to 6 months, and the big ones take 2 years.
Oh, well, cool.
Yeah, one of the things you can do in Hawaii is go to the Whaling Museum on Lahaina, and I think I still have my little scrimshaw kit, which I don't think had ivory in it. It was something else you could carve on, but you could pretend to be a sailor from days of old and carve something on it. So like old sailors used to do.
And we thought a robot took a long time to build.
Yeah.
Right.
Anyway.
And another fun tidbit. He said his smaller models have 2,000 to 4,000 parts, and they're not held together with glue. He drills holes, sometimes a couple diameters of human hair. He drills holes, and he used pegs, ivory pegs, to hold the parts together, with the only exception being the rungs on the rope ladder, which he glues on with white Elmer's glue.
Oh,
Pretty crazy.
So if you find yourself in Ohio or you want to have an interesting tour, that's I highly recommend it, especially if you can find a place they'll get the main guy there to explain his trade. It was a great evening.
cool.
But back to the heat
John,
shrink. I want to thank everybody for the discussion of heat shrink, and I don't want to detour things too far.
I think John was up next.
Yeah, so I've got a few different things. I mean, last week I showed that balancing robot.
Yeah.
Had a little mishap, plugged in something backwards, and blew my ESP32. So I decided to do a slight design change, and I'm going to share my screen here. So this is the new design here. If you guys can see this. So I basically decided to design a PCB to put all the almost all the electronics on. The IMU is still going to sit down here, but the rest of it's going to be on this board. So I thought maybe you guys might be interested in the sort of the go away, stop. The design process for a PCB using KiCad. I can do a 15-minute quick overview. So I'm going to share. Well, I'll try my screen. I mean, this is a big 4K monitor, so hopefully it's not too bad. I don't know if you guys can. Let me zoom in a bunch. If you can see this, can you see that? Okay.
Oh yeah.
Yeah.
Okay. So the basic idea here, I have this is the schematic, which you do first, and I've got a few components on here. I've got a tiny S3, and I grabbed this component from the Unexpected Maker site. He has, well, I think he's got it on GitHub or somewhere. He's got the KiCad schematic and footprint layouts for a lot of his stuff, including the tiny S3, which is the board I'm using. So basically, you put that down. I like to use labels to so I don't have to run wires all over the place and make a spaghetti mess of wires. So as long as the labels have unique names on them, and the nice thing about that, I'll show you when we get to the PCB, that it also labels the traces, which is nice. So we've got a tiny S3 here. I've got a Palalu DRV 8835, which is one of their little 2-motor driver boards. This is a voltage regulator, one of those 5-volt, 5-amp ones that I use. I have several of them. And there's a power switch and a plug. I've got it here as a terminal thing, but I ended up just using a regular header, which I'll show you. So basically, when you're doing PWM on motors, and especially through this thing, you need basically 2 lines per motor to control it. In classic PWM, you'd have a PWM and a direction. These ones are a little bit different with this motor driver. There's a different way you can set it up. So you end up alternating which one you're PWMing and which one is a direction, but that gives you braking on the wheels, which I think is valuable for a balancer. So anyway, this is an ESP32 S3, so you can make pretty much any of the I/O pins hardware PWM. So 2 control pins for the right motor, 2 control pins for the left motor, and then each motor also has an encoder. So I have basically a right A and a right B and a left A and a left B. Quadrature encoders usually have an A-B channel. And so I have a connector here on the board that has 3.3 volts and ground, and then in this case, this is for the left encoder, so it has left A and left B. And one of the things that you pay attention to as well is the ordering of these things. Ideally, you want the order of your connectors to match the ordering on the actual board, so that it, you don't have to twist the wires all over the place and stuff. They just end up being a nice flat run. And so the right encoder, I've got, I decided to put in an extra I2C connector. And I'm glad I did, because I'm going to switch right now. I was using the IMU in UART mode, but I'm going to switch it to use it in I2C mode. And I'm going to use this UART to talk to the camera that I'm going to be adding to this board, which I'll talk about in a minute. I also added a little LCD panel to the front. It's one of those little I2C OLED ones that are 128 by 64 pixels. They're kind of cute. It'll just be for displaying like the battery voltage and status stuff. You could display the IP address of the tiny S3 if you've got it set up like that. And then I've got a head I2C pin header, which basically gives me 3.3 volts ground and SCL and SDA to go up to the head, because I have 3 time of flight sensors on the head, although that's going to change to 2, but we'll get into that in a minute. So I basically send up the head I2C and then the shutdown lines for the sensors in a separate connector. So these are the things that show up on the main board. And then I've also got a battery voltage divider. So if you take this pin here, this is the battery input. So this will be like 7.4 volts nominal. I mean, it's up to 8.4 volts. It's a lithium ion battery. So when you turn it on, then this line right here is battery positive, and this side is ground. And if you put a 10K and a 5K, you're basically dividing the voltage by 3. So this gives me, DigiKey has a neat little voltage divider calculator. You can punch in the values and it'll tell you what the output value is. Or you can just sit down and do the math yourself. It's not very complicated, but this will basically give me a max of 2.8 volts. And since the A to D, this is the battery line here, the A to D can read 3.3 volts, then that's no problem. So I won't have to worry about, and you basically read in the value and then you multiply it by 3 and that gives you the voltage. Yeah, so what else? Let's see, I've got a servo on the head, so I'm controlling the servo with this line using hardware PWM, and I've got a 3-pin connector which has the control pin, 5 volts from the regulator and ground. I put it on an auxiliary power connector, and I'm kind of glad I did because that's going to power the camera. And yeah, I think that's, and these are the motor outputs from the motor driver board. And I put a big ass polarized capacitor right next to the motor driver so that it can hopefully absorb some spikes if it ends up producing any. So that's the schematic.
Where's the regulator for 5 volts and 3.3?
The 5 volts regulator is here. The Tiny S3 produces 3.3 volts. It has a 700 milliamp regulator on it. And
Like a
so
linear.
it's going to use, well, I don't know, whatever it is, it's going to use, 100 or 150 milliamps if you're going all out. And so, you've got 500 or so milliamps of 3v3 here. So that's enough to control, the encoders take virtually no power. The time of flight sensors take very little power. The LC, all of this 3.3 volt stuff doesn't take very much power. So I'm just powering.
So that Palullo part, the produces 5 volts, is that a switching regulator module?
Yeah, it's a switching regulator.
Cool.
And like I say, it does 5 volts and 5 amps, which is kind of overkill, but I happen to have a few of them, so why not? So when you go to create a schematic from this, there's a couple things you have to do. The first thing you have to do is you have to do what's called assign footprints. And so each component on the schematic that's named, you have to say what footprint it will have in the PCB. So this 680 is a radial capacitor, diameter 8 millimeters, with a pin spacing of 3.5. And it happens that I have some 680 microfarad capacitors that fit that. And the battery is a Molex Spox, which I'll show you in a bit, and the left motor and right motor are the same ones. Those are the sort of the bioloid type connectors. I've showed them before that they're polarized and sort of actively snap into place. So these are 2-pin for power and ground, or in the case of the motor, motor 1 and motor 2. All of the other electronic stuff is using high-rose DF13 connectors, which are like half size. Instead of being a 0.1 inch or 2.5 millimeter pitch, these are 1.25 millimeter pitches, so they're a lot smaller. And so you can put a lot more of them on the board without taking up as much real estate. And those are also keyed, so you can't plug them in backwards, and they're actively click in place, which is nice. The LCD has a regular 2.5 volt socket that I put in. The aux 5 volt is the same as the other power ones, the Spox connector. The head shutdown is a high-rose one. I've got a couple surface mount resistors for the voltage divider, just because I've got like bags and bags and bags of 603 surface mount resistors. Then I have this slide switch. It's a 5 amp slide switch, these red ones that I use from DigiKey. So that's a standard part that I use. And then there's the Tiny S3. This is a DIP 14, which is the DRV motor driver board. And this guy is, oh, that's the voltage regulator. It's just a 5-pin header, basically, a straight header. So you apply that, and then what you do is you go to the schematic. So I'm going to close this now, and you go to the PCB. And I'll zoom up here, and you can basically update the PCB from the schematic. And what that will do is it will take all of the footprints that you have and stick them all in a pile, and you basically then lay out what your board outline looks like. You can set the grid to be various different sizes and stuff. And so you lay out what your board outline looks like. In this case, I have a ground plane on the back. The green part here is a ground plane. So all of the ground connectors you can see, like if we look in depth here, you can see ground. They have connectors to the ground plane. And it turns out that this little thing here is an island. So I have to provide a bridge to the main ground plane in order to make that work. So I did do that there, but the rest of the ground plane is connected electrically everywhere. So these are the high-rose connectors, the little tiny ones here. This is a regular servo connector, like a 3-pin, what you'd normally see with a servo. This is the LCD connector here. The Tiny S3 kind of goes in the middle, so the USB port will be hanging off the back here. So it'll make it easy to program. The power switch is a right angle switch, so it sits here and switches on. Here's the battery connector, left and right motor connector. This is my aux 5 volt piece over here. And this is the motor driver board here with that big capacitor and the 2 motor connectors. And here's my
Does
little.
it point out the islands to you?
What's that?
Does it tell you where the islands may be? That
Yeah, so it has this thing called a rat's nest. So what I'll do, I'll delete one of these lines that I have here. So here, I'll delete this line because that'll make it simpler. So if I delete that line, you can see suddenly there's this, if you look here, there's this thing that says, hey, this is supposed to be, this is ground, but it's not really connected to ground. And so if you turn on and off the rat's nest, that goes away and comes back again. And you can also do what's called the DRC, which is one of these, this guy here, design rules checker. So you can run DRC and it will tell you if you've got warnings and errors. So I've got a board edge violation, which I don't really worry about too much. And silk screen issues or warnings, which I also don't worry too much about. And somewhere in here, let's get rid of the warnings and just look at the errors. Edge cuts, board edge. Yeah, it doesn't really consider that an error. Oh, there we go, unconnected items. So this zone is, this ground pad here isn't connected to the ground zone. So that's an error. So now I can basically just go here and make sure that I'm on the top layer. It's current, and I just hit X, which starts. Actually, I want to change my track size to 0.75. So I'm going to hit X and go like that. And I hate it the way it does this sometimes. So now I have that connected. And now if I rerun DRC, you can see there's no unconnected items. So board edge clearance is really about the fact that the silk screen hangs over, or the you know, whatever hangs over the edge of the board, and most PCB companies don't care. They'll just print the silk screen, and when they cut it, you'll lose some of the silk screen, and it's really not a big deal. They also complain about these as being vias. These are my mounting holes. So it's basically a 2.2 millimeter. I just make them as 2.2 millimeter vias because I'm using an M2 screw to hold it in. So I've got one of those on each corner. So yeah, and then it's just a question of laying these things out. And when you lay these things out, you know, when you use a ground plane, you hit B and it recomputes. And there's somewhere in here, there's an actual command. I don't remember where it is, but fill all zones. There it is. So if I unfill all zones, the ground plane isn't there anymore. I mean, I've got the outline of the ground plane, but it's not there. So when I go then and go back to fill all zones, then it recomputes all of the pins that are supposed to be grounded and whatnot. And in fact, you know, if I was smart, I would take these two
and just move it down
here, and that was annoying. It's supposed to do those together. Oh, because I've got a via there. That's what's wrong. I'd have to move that via too. So if I move that via down to there, and then move that guy down to there, and then move that guy down to there, and I think, yeah. And so now if I hit B, then that's no longer an island.
Right.
So now I could get rid of this thing. I've already sent the board off for manufacture, and in fact, it's in DHL's hands. So it's going to show up here later this week. But yeah, so that's the PCB. I designed it. It took about an hour to do the schematic and a couple hours to do the PCB layout. It's been a long time since I've done one of these, but I've done a lot of them in the past. So yeah, that's it takes a little while to get used to the user interface in KiCad, but it is reasonable, and it's open source, and it runs on pretty much all platforms. Like, I'm a Linux user. I'm running on Ubuntu Linux here. So that's one of the reasons why I use KiCad, because it runs on Linux.
John, which PCB shop are you using?
I used PCB Way.
Okay.
So it decided to try them this time. I normally use dirty PCBs, or at least that's what I used to use. But decided to try PCB Way this time. So yeah, it's a nice setup, and oops, let me get out of there. It's a nice setup, and it's a simple editor, and you know, you can do all the things you need to do. Create the Gerber files and that sort of thing, and then package them up and send them. One of the other things that I thought about doing with this, so I've done a couple different things, and I'm going to stop presenting for a second here, so I can show you. So these are the motors that I had in it originally, and these are Polalu gear motors. These ones are 100-to-1, and I had them for a different robotics project I did like 10 years ago, and they've got optical encoders on the back. So you can see the little fan there, and there's a couple of optical, basically an IR transmitter receiver pair that can see the transitions between when the fan is in front of it and when it's not. Those are kind of annoying for a couple of reasons. One of them is that because of the way that these things are mounted, and I had them mounted inside this piece here, so they went in there like that. Because of the way they are mounted, you can see that wires get kind of pushed down on top of the fan, and I didn't like that, and whatnot. So I decided to get, and if you look at the PCB, you can see that, you know, it's got holes in the PCB, but they're in behind the fan. So it's kind of a bad design. But I mean, it was a long time ago when I bought these. So I got some new ones. These are 75-to-1, the high power carbon brush motors from Polalu. And these are a magnetic encoder. So it's got a magnetic disc on there that rotates in a couple Hall effect sensors. But the important part is the PCB, the holes are up above where the disc is. And it's kind of funny because the holes are actually at a 2-millimeter pitch. These holes, the 6 holes, they're at a 2-millimeter pitch, and I don't have very much stuff that's 2-millimeter pitch. But as it turns out, somewhere along the line, I bought some. So this is like a 4-pin right angle 2.4, 2.54 millimeter pitch. And this is a 4-pin right angle 2-millimeter pitch. And you can see how much smaller it is, even though it's only like 0.5 millimeter pitch less. But it's a tiny little connector, comparatively speaking. And so I basically took, I had like probably 8 or 10 of these things. And so I took them and basically slid this plastic part along here and then cut the bend off so that I had a 4-pin straight. And then I cut one of them in half so that I had a 2-pin straight. And so that gives me 6 pins. And then I soldered them onto that. So now I can, with some heat shrink, solder the wires to this connector without having to worry about them touching the magnetic encoder disc. So that's kind of important with these things, and these ones fit inside there pretty nicely, and so they're held on this end by these 1.6 millimeter screws, and then it goes in here, and then of course the body, it just fits onto here, and there's 3 M3 screws that hold that in place, and this has a hollow in the middle, and so the wires from the encoder and the motor go into this. And then if you look there, you can see there's these 2 slots. Well, those 2 slots are open underneath, and so the wires come up through those slots, and then they'll go up and attach to the PCB. So I can show you that in the model. So let's go around to this side. So this is the IMU shelf, and I make these things removable because the screws come down from the top, and you can't put a screwdriver in here because there's a whole pile of stuff. So I have a couple of M2 screws here that hold it to the frame, and then the IMU gets attached to this piece. So we'll make that thing, IMU mount, go away. And then you can see, and I will grab that and that stuff and hide it. So you can see inside here, there's these channels, if I highlight them, and it's basically this piece here. So the wires just come out here, and then we'll go up to the PCB up here and plug in. So you can see there's a square hole on the inside of this thing. If I take that and I say hide other parts, there's actually a square hole that the gear head, because the gear head is rectangular, it's 10 by 12 millimeters, that fits into there. And then the encoder piece and the motor body sits there, and then the encoder piece is sort of out in this little area here. So yeah. So the other thing that came up that was interesting, I've been a big fan of OpenMV cameras for quite a while, but they're way too big for this robot, because their OpenMV cameras are enormous, like, you know, comparatively speaking. But it turns out they have this new one. I mean, they've had it for a couple of years apparently, but I never really noticed it. It's an Arduino Nicla Vision. And it has a camera. It's got one of those the heavy duty time of flight sensors, the ones that do the whole like 8x8 or 16x16 or whatever grid pattern. It's got an ESP32 on it. Not an ESP32, sorry. It's got an STM H7 main chip, which runs MicroPython. And so it turns out that the way this thing works, like all OpenMV cameras, it's got basically an STM32 on board that you program in MicroPython. And the guy who invented OpenMV has built this whole library, which is basically a sorry, let me stop sharing here. It's basically a light version of OpenCV. So you can do all of the stuff, well, a lot of the stuff that you do with OpenCV with an OpenMV camera. But the neat thing is that it's not a camera, it's a smart camera, because the code runs on the camera. So my Tiny S3, which controls the robot, doesn't have to do any of that OpenCV stuff. That all happens on the camera, and they're connected via a UART serial port, and I can just send down interesting metadata about what the camera sees and what it's interpreted to the Tiny S3, which then makes decisions about where it should go based on that. And you can also, you know, because it's got that time of flight sensor on it, you can get information. So it's effectively a depth sensor, because it's a grid, you know, pattern type thing, plus a camera. So it's almost like an OT light from that perspective. And you're running the code to process the image on the camera, the same as you do on an OT light. You can actually run machine like TinyML models on it too, although I'm not really interested in doing that for this particular one. I'm much more interested in doing, you can do things like find lines in the image. You know, so if you've got tape on the floor or something like that, like you would have on, say, a Quick Trip board, you can find the math equations of those lines with the library. And it'll just give you back the numbers, you know, the start and end kind of points of the line. And you can then hopefully interpret from that where you are relative to where you want to be, and make corrections.
Can you post a link to that camera, John? And,
sure.
And also, one question I didn't quite follow. Does it have one of those time of flight 8x8 sensors as well as a camera on it?
Yes. Yes, it does. You can see it. If you look at that link, if you look in the picture, the sensor is literally right below the camera.
Nice. Wow.
So it has, this is the post. That's the type of the time of flight sensor that it has on it. So, and the neat thing is, OpenMV. So if you look at, I'll paste a link to the sort of the main library. That's the image library that you have access to, which gives you, sort of the machine vision OpenCV type stuff. So you can do April tags and QR codes. You can recognize circles and do color blob tracking, and it has optical flow stuff, and there's thresholds and histograms and just all kinds of stuff that's, taken from essentially OpenCV and implemented it's all implemented in C, but it's accessible from MicroPython. And he's got a really cool IDE that you install on your computer, and then you plug the OpenMV camera in via USB, and you can run the MicroPython on the camera and see what its output is. And you can draw things on the display the same as you can with OpenCV and stuff like that. So you can really get a feel for how to tune the image processing capabilities to produce, the results that you're looking for. So I'm looking forward to playing with that.
Wow, that's pretty neat.
Yeah. It's basically the same IDE that the OpenMV H7 and H7 Plus and all those.
Yeah, I mean, this is the OpenMV camera that I have. I mean, I have the original one too, but it's tiny. But this is an H4, I think, which doesn't support a bunch of the things. Although this one I've got an LCD backpack on it.
Right.
But this one does, a bunch of stuff. I mean, you can do color blob tracking and a bunch of other things with it, but the new one has a much more powerful processor that allows you to do a lot more interesting stuff.
Yep.
So next year, look for a 2-wheel balancing robot that can do quick trip and 4 square and 5 square and all that jazz.
All the squares. Yeah.
Awesome.
Squares. Yeah, and I've got these are tires from an RC rock crawler, 24th scale RC rock crawler. They're very soft rubber. I've actually got 3D printed TPU inserts inside them. And so these are what are actually on the robot as tires. So kind of cool. Yeah, and this showed up in the mail today.
Ah, excellent. Excellent. I'm glad you got that, John. Cred, oh, and you got yours too, Tom. Excellent. Creds to Doug for cutting them.
Mm-hmm. Yeah, so I think that's everything that I've got. I ordered the sensor from DigiKey, so the camera. So I'll get it tomorrow, and I'll be playing with it over the weekend and stuff. Although I won't be here next week on Tuesday because I'm going to be driving back from Toronto on Tuesday night. So
You ordered the Nicola Vision.
Yeah.
From DigiKey? Cool.
Yeah, they stock it. It's 115 US from OpenMV. It's like 167 from DigiKey, which I went to Google and said 115 US dollars to Canadian dollars, and it said 165. So 167 is good enough for me. And free shipping overnight.
Can you stick different cameras on it or different lenses?
No, the OpenMV cameras you can. They have basically detachable. Well, this one doesn't, but the newer H7 ones and stuff, they have detachable lenses, and you can get different parts and pieces and whatever. They even have a thermal camera that you can get.
Right, a FLIR. Yeah,
which is kind of cool.
Mm.
Yeah, if you go to that OpenMV.io website, they have several different cameras available.
Yep, global shutter, a FLIR sensor.
Yeah, and they've got a zillion shields and lenses and all kinds of stuff available. for these cameras, different things, because you can use this, like, you know, with an OpenMV camera, you can plug in a pan and tilt shield, which basically allows you to control a couple servos from the camera directly. So you can have the camera track something automatically and you know, pan and tilt to follow it. And you know, that's one of those classic OpenMV demo type things. I'm actually controlling, I have a tilt servo on the head of this robot, so I'll be able to tilt it forwards or, you know, tilt down or look up. And of course I can compensate for when the robot is tilting to move. I can have the camera pointing straight ahead by just compensating for that with the servo. And of course the balancing robot you can spin on the spot, so that's the pan capability.
A kind of off topic of the robot and the camera, what is the relationship between Arduino and OpenMV?
So
Are they related?
they're not related. Arduino came out with this cool camera thing, and I don't know if they did it as a joint project or what.
I think they did, yeah.
Yeah, they might have done it as a joint project, and they basically, the idea is that, you know, they supplied the hardware and OpenMV supplies the firmware that runs on the camera to make it useful. And you could, like I say, OpenMV has the capability to run models as well, you know, with the TinyML stuff or Edge Impulse. So you can do model stuff. You know, if I was just going to do model stuff, I would just use this camera, which can run models as well, but that's all it can do. It doesn't do any sort of OpenCV stuff. And I'm more interested for this robot in the OpenCV stuff than doing, you know, object detection and stuff like that.
So, I think if I'm understanding this correctly, the camera that you just showed might be suitable for Robo Columbus.
Oh, absolutely.
Because you could run the code recognition, the cone recognition model, and also use its path proximity distance sensor to spot the cone from a time of flight perspective.
Yeah, and the neat thing about it is, you know, you can run a model, but, you know, inferencing isn't going to be that fast. I mean, it'll be okay, but it's not going to be that fast because it's not a super powerful processor. But if you recognize the cone, then you could switch from model mode to OpenCV mode and start doing color blob tracking based on the color that the camera can see there, because of course the model will tell you where in the image the cone is. So then you can, you know, pick a spot that's roughly orange, and that's your sort of the center of your threshold of your orange color blob detection, and then that you can run at like 30 frames per second on that camera and use that for the close approach to do visual servo. So that's the other really nice thing about that camera is it's tiny. It's a little less than an inch by an inch, which is the reason why I bought it, because it will actually, you know, this is the head that I have for my robot, and it's got like the holes for the time of flight sensors on the side, and I've modified the model so that I can, you know, I'll show you here actually. I've modified the model so that I can, sorry, just a sec, go over here. This is the CAD model of the head, of the new head. Onshape ever decides to finish doing this. There we go. So this is the size of the camera. It's a very small, like that's the PCB board from the camera. So it's a very small board, and it fits inside the head basically. And it gives me, you know, I don't need the time of flight sensor on the front anymore because it has one built in. So just the two on the side.
Cool.
Yeah, I know one of those time of flights can tolerate brighter light than the other one. I forget. There's a 7 and an 8 in the part number, but I still think it might not work in bright sunlight, especially in the Texas sun.
Yeah, and as Mike pointed out, this particular sensor, I think he's right. It's only a 4x4. It's not the full like 16x16 or whatever. So, but regardless, it's still, you know, if you sweep it around a little bit left and right and you know, tilt it up and down, you can compensate for that nicely.
Wow, you got a lot going on there, John.
Yeah, I usually do. I'm hoping
3D.
that this robot's actually going to work, and you know, I can actually start playing with the code a lot more.
Very cool. Thank you for that. Let's see if no one has any other questions for John. We will move on to Doug.
So I've been playing with PyDog, but I haven't got anything to show. I was hoping I would. You can skip me.
Okay. Well, that was the end of the list that we accumulated before we started. Oh, Tom, did I not put you on the list?
No, I was late joining, so I'm not on, but there is a little bit of work I've done that might be of some interest. I'll present a window here. This one, if I may. As I mentioned to some of you in the past, why is it asking me that? I'm moving from Arduinos to Raspberry Pi Picos as the single board computer of choice in my workshop. And I've had them for a while, and I've just started to play with them, and I'm getting serious about putting one on a robot. That means I have a lot to learn, and in particular, I need to build a single board development and expansion environment that I'm comfortable with, that matches what I've been used to for years with Arduinos. But when you buy a Pico, you don't get much. And the Pico itself doesn't have much. Depending what particular brand you buy, it may not even have anything beyond a simple LED on it for purposes of any external I/O. They have serious voltage limits for the voltage you can feed them. Their outputs are all 3.3 volts only. A lot of the stuff I'm comfortable with is 5 volts still. They may have a power LED, they may not. They may have a reset push button, they may not. I did a presentation on the several varieties of Picos that I have bought in the last several months, and there are quite a few differences between them. What I'm used to is more like this. You're familiar with this robot that I entered in the Robothon. It's typically got an Arduino Uno on it with lots of connector I/O on it, and it's comfortable with whatever voltage I feed it within limits. I tend to add LCD displays, push buttons. This one has a bunch of LEDs back here sitting on an I/O expander, which makes it easy to quickly give indicators for what's happening internally. I like I2C, so I tend to put a block of I2C connectors. Excuse me. When there's RC servos, you'll need a block of RC servo connectors. There's never enough 5-volt power on these things, so I always add another 5-volt power supply. And although it's not showing in this picture, 1 or 2 simple analog input pots are really handy for testing various things in addition to push buttons. Excuse me. So this is what I'm used to, and this was the sort of thing that I started to look towards putting together that I could run a Raspberry Pi Pico with, something that gives me a better development environment with more little toys attached to it, as well as being able to use it to quickly expand into other devices and sit it on top of a robot. I'd started to take a look at what's available. There's tons of stuff available. This is just a quick survey. The upper left, there's a gadget called a Pico Explorer. I should also mention I'm cheap, so I put the prices in here, but I'm not about to go out and spend the money on these things. Pico Explorers are kind of nice as a development environment. They're a little pricey for me. These prices are in Canadian prices. There's not much point in me buying stuff from the States. The shipping is very expensive, and I might just get hit with customs as well, depending what it is. So I either buy from China or I buy domestically. So these tend to be domestic prices or AliExpress prices. This item is from PiShop, the priced from PiShop. You get everything that shows in the picture except the Pico. So it's kind of a nice development tool, but it's not very useful as an expansion tool. You'd have to add a bunch more stuff to it if you were going to drop it onto a robot, for example. The one to its right is a little better from an expansion point of view, and it's not very expensive, but it doesn't do much from a development point of view. There's no displays, there's no push buttons, there's no other devices that are readily available to attach, although it does have a nice block of connectors on the end that are configured by function, like I2C or UART. So that's kind of nice. Again, moving to the right, this particular unit is a Cytron expansion board. It's pretty nice if you like I2C. It's got a lot of, I believe those are Gemma connectors down both sides. It's got an SD card slot. It's got a few push buttons and a buzzer. Not much else. Not badly priced. I was surprised that it was $12 at DigiKey in Canada, which is not a bad price, but there's still shipping on top of that. John can confirm, but I don't think I get a shipping break until I spend $100 or more at DigiKey.
Yeah, it's $8 flat shipping,
Okay.
unless you spend $100 and then it's nothing.
Yeah, I threw in the two pictures on the bottom. They're out of a very nice lengthy video by DroneBot Workshop a few years ago when he went down the same road. He wants to switch to Picos from Arduinos because he's always been a big fan of Arduinos. But he needed some way to make it look a little bit like an Arduino development environment. He prototypes a lot with Arduinos, as do I. So he has several suggestions. I put in a couple of them just for reference. Basically, take a perf board, add a whole bunch of connectors, add some push buttons, add a voltage regulator, and away you go. The one on the left is a very basic solderable perf board layout, which you can get anywhere for a few dollars. The one on the right's a little fancier because it tends to have some defined sections on it for things like power supplies. Excuse me. Although it's a little pricey, I thought, as a bare circuit board. So not something that I was too keen on. I did begin to build my own because I had to make some progress. So here's some pictures of the development board that I have built and which I'm currently using in my learning exercise. And as I develop the code or redevelop the code that I want to use to run on a robot with a whole bunch of peripherals on board. So this has turned out fairly well, although it's a little tedious to build it up from scratch. When you put together and build the first one, you might spend a whole day at it. It's got an OLED display, lots of connector points, both male and female, on both sides of the place where you plug in the Pico. For the purposes of this one, I've got 4 push buttons, 4 LEDs, all on an I2C expander. I wanted to play around with Wi-Fi. I've never used Wi-Fi with a robot before. So in the bottom left corner here is an ESP01, which interfaces very easily and neatly to Picos over a UART port. I haven't done much with it yet, but it's there and it's running. I've added blocks of I2C connectors for both 3.3 volts and 5 volts. So there's a 4-channel level converter in here as well, of which 2 channels are used for the I2C. I've placed an MPU 6050 IMU on board this thing. They're really easy to use. I've used them before. I have a little bag full, so I might as well use one. So there's a small IMU on here. I've added an additional 5-volt regulator. And normally I would add an analog pot, 1 or 2 analog pots as simple variable inputs. But I also have a bag full of rotary encoders, which I've never used before. So there's a rotary encoder stuck on the side here, which is currently working, although it's working in interrupt mode. One of these days, I'll get somebody to help me with the necessary code for the programmable I/O in order to move everything into the PIO state machine. I've been looking at code, but I'm going to have to work at it because nobody's got a drop-in-place solution yet that I found. So that's what I'm working with right now. And I thought that was pretty neat, but I want more. This is a one-off at this point. And I can clearly see that I'm going to configure several more just to have around for prototyping purposes, experimenting, a couple more robots. We'll see where it goes. So I started to take a look again at what was out there that might be easily configurable after having spent a day building one or 2 days. And I ran across this particular bare board design, a Kiwi Kit Pico. It's 10 centimeters by 10 centimeters, so a little bit bigger than the unit that I built myself. Because the Gerber files are readily available and have been successfully built before, I decided to buy some. So I sent in an order several days ago to Next PCB, happens to be the shop I picked, because I'm a new customer. And because I'm a new customer, the cost of my 10 boards at my address will be $1.98 US. So that's pretty cheap. And this is not a bad looking board. It doesn't have everything I want, but it's got an awful lot, and the rest should be very easy to add. So it'll be a couple of weeks before I get this, having only paid for China packet service or whatever it is. When you ship from China, from my point of view, I do not want this to go through any of the brand name couriers because they probably have a $50 admin fee to get my $2 worth of boards into the country. I don't want to pay that. If it comes to Canada Post, I don't have to pay any of it. So it takes a little bit longer. This looks like a very useful board. There's the bare board on the left, and this is an example of the populated board on the right. So it's configured for push buttons for OLED displays. This particular designer stuck a double EEPROM socket on. He said because he had a bag full of them. So it's got an additional double EEPROM socket. It's got nicely configured I/O sections in logical functional blocks. I wish it had more I/O connectors, but I can make do with what's there, I think, for the moment. We'll see how this works out for about 20 cents a board. I have most of the parts to populate a bunch of these already, so it'll be pretty cheap. Now, while I was digging out these pictures to put together this presentation, I ran into one more public domain board design. This particular one called, let me get my mouse out of the way, called the Shabazz Eurocard Pico Development Board version 2. It's about 10 by 16 centimeters. It's a standard Eurocard size. You can learn more about it from the Element 14 community website. Just Google Shabazz Eurocard Pico and you'll come up with it. There's also, Element 14 does a series of hobbyist level YouTube workshops. And this one is featured in a couple of those workshops as well. So there's a lot of detail on it. It's very impressive. Again, doesn't have everything I would want, but it looks like a very nice board. And if you could get these things made for 20 or 30 cents a piece, that might be quite a deal as well. They look very nice. They have a big prototyping section on board. They also have, I don't want to go into detail on this because I just discovered it today, but sitting up in the corner here is an ESP32 micro board, mini board. And it's configured with software to turn it into something called a Pico probe. Basically, it interfaces to the Pico through its debug interface. And it runs a bunch of software in order to allow hardware level debug. I've never used that, so I may be expressing this incorrectly. But if you're really serious about debugging at a low level on a Pico, that might also be a handy thing to have. Anyway,
can you repeat what the ESP32 is configured as? I had to drop out.
The term that is used by the developer is Pico board, Pico board, or so I'm sorry, Pico probe. PROBE. And it's essentially a programmed interface to the hardware debug interface, the 3 pins that hang off the end of a Pico. I think it's a JTAG interface, but I'm not sure.
Thank you.
So never having used one, but it certainly sounds like an interesting thing for people who are willing to do hardcore debugging on a Pico. Any questions? Anything else?
So
Hey,
the only,
have you ever seen, there's another Cytron board. If you look up MakerPi RP2040, it's got motor drivers,
Oh, yes.
LEDs. So you've seen that one then?
Yes, I saw that one as well with the motor driver on board. It's kind of a
it's
low current motor driver, but it looked interesting as well.
Yep. Yeah, and I thought it was very reasonable, like $14 or something.
Yeah. Up in Canada, we double that.
Oh, you double it? Yeah.
Probably. Yeah. By the time it came out of my pocket.
Anyway, I want to say, I thought Dave Ackley was using one of those. That might not be right, but I thought it was him. And I thought, I don't know if Doug's still on. I thought Doug had some interest in that too at some point. Because it was kind of a board that had, integrated a lot of stuff and actually had motor drivers on, two motor drivers for 2 wheels, basically, or 2 motors.
Okay.
Anyway,
I configured my homebrew version on this 8x10 board because I happen to have a bunch of them. I tend to use what I've got a lot of, and it's a convenient size to position on a robot chassis. That's not too big and not too small. So I have a bunch of these. That's why I picked that size.
Yeah, the interesting thing, like you're using one of your Pico sort of compatible boards.
Yes.
And as you pointed out, they all seem to have different pinouts. So you're going to have to be careful because, of course, if you use any of those other boards that you found, they will only work with a real Pico pinout.
Exactly. That's a good point, John. That's why I did the spreadsheet back a month or 2 ago when I discovered that the units I had were not identical. So,
yeah. One of the other boards or chips that's really interesting, if you decide that you want something with a little more capability, the STM32 F405. These boards you can buy on Ali for like $11 Canadian, and they've got all kinds of capability, including, they're 3.3 volt chips, but all the digital inputs are 5 volt tolerant, and it's got all kinds of hardware timers and PWM and UARTs and I2C and SPI and everything else under the sun.
5 volt tolerance would be very nice.
Yeah, it makes a pretty big difference. So.
Just curious, Tom, what was your decision process in, stepping away from the Arduino R3 with its the old 8-bit processor makes a lot of sense, but what was your thought process on choosing a Pico versus an ESP32?
Good question. And I also have another half a dozen ESP32s here of various types, which I've tinkered with. Probably the biggest reason is the Pico has more I/O on its basic board for $3, because basically they're costing me $3 Canadian. So it's got a lot more I/O pins, and I find that nice. Slower processor rate, but the programmable I/O machines that are embedded in it are something that I'm looking forward to doing more with. Also, I just discovered in some other things I was looking at a few days ago, although the Pico is only running at typically 125 megahertz, apparently they overclock very nicely up to about 250 megahertz. And I'm curious to try that some more as well. I don't know if anyone else has any comments or experience on overclocking them, but Some of the stuff I've looked at said they run just fine at 250 meg. That puts them in the same ballpark as ESP32s.
Yeah, 240, I guess.
Yeah.
Tom, I pasted a link to a MicroPython forum where they talk about quadrature encoder PIOs. Now, this is in the context of MicroPython, but the PIO code is PIO code.
Yep.
It's assembler basically. So they talk about how to do quadrature encoding using PIOs and that sort of thing.
Your brother's done some work on PIO programming as well, I notice, on his GitHub. Also, Adam Green, who's a member of the Vancouver Robotics Club, has done some work. He's done some for Pimoni, I believe, or Pimoroni, whatever they're called. So he's another resource I may call on as well. Mostly, I just have to sit down and spend a day going through the details and do some trials. I've got half a dozen quadrature encoder code blocks, some with test routines, some without, some with explanations, some without. And I've just got to sit down and apply some rigor to studying them and experimenting with them. And I just haven't done it yet.
Yeah.
That was part of the reason for picking the rotary encoder to add to my development board, was because that's a good example, and a simple example to experiment with that. One of the forum items that I was reading that covers quadrature encoders with rotary encoder styles is the fact that you need to be cautious about noise, especially with cheap rotary encoders.
Debouncing is really important.
Yeah, and I don't know whether you can include the debounce inside the encoder, inside the programmable I/O structure. I don't know enough about it yet.
Yeah, I don't know either. One of the interesting other things that I forgot to mention about the STM32 board, these chips have the capability, you can hook up a couple of the 32-bit timers to, or 16-bit timers if you're just doing a rotary encoder, but for actual doing like motor encoders, you can hook them up in quadrature encoder mode, and it will actually read and process the quadrature encoders in hardware completely.
Very nice, very nice.
So that's kind of a neat capability. So you can basically control two motors and read their quadrature encoders using one of these guys, using zero of the processor power. You still have 100% of your MCU capability available.
Yeah.
On top of that.
Well, Paul asked a question about my choice of Pico versus ESP32 in terms of moving forward. Paul, there's one other aspect of that, and that is I'm really nervous about moving away from the Arduino IDE, a C++ environment, into an interpreted language like Python. But I figured the only way to learn something new is to dive right in. So another reason, I know you can run MicroPython now on all of these embedded computers, but it initially came to my attention with the Pico, and the infrastructure for managing that looks good. I'm getting very comfortable running Thani. I'm really beginning to enjoy the extremely rapid debugging turnaround. Yeah, John's nodding his head. John said this. You're absolutely right, John. It is great. As I make all these little bits and pieces work on my development board, I can just make them work in fractions of a second almost.
Yeah, no, it's awesome.
It's really nice.
So these are a pair of Zao boards. This one is an RP2040 Pico, and this one's an ESP32, and of course they both run MicroPython equally well.
Yeah.
As does this STM32 board runs MicroPython as well. And
I'm getting comfortable enough with the MicroPython that I may take a few of those ESP32 boards I have and load load MicroPython firmware into them.
Yeah, well, that's all I use. So this balancing robot is using a Tiny S3, which is an ESP32, and it's programmed in MicroPython. And I posted a link to my GitHub for that robot, and you can see my code in there for controlling that robot.
Great. Anyway, that was it. I thought that was a lot of fun.
Cool. Thanks,
Yeah.
Tom.
Once you start playing with MicroPython compared to programming in C, you realize, yeah, interpreted languages are slower, but holy crap, your productivity is so much higher.
Yeah. Now, one of these days I'll have to learn something about freezing the bytecode, which I understand can speed things up, but right now it doesn't matter.
It really doesn't matter. I virtually never do that. If you're building production stuff, it's useful, but if you're not building production stuff, it doesn't matter.
So my next exercise will be to connect my my little Pico development board up to the motor drivers on my robot. See if it'll actually make it move. We'll see what's next.
That's
Should be
a
easy.
pretty neat development board you put together, Tom, and you've been pretty busy as well.
It's worked out well, and of course, for me, an awful lot of the pleasure of this hobby is the path, not just the end goal. So I learn a lot and enjoy producing things that actually work.
Cool. Well, if we don't have anything, no one has any more questions for Tom, and no one has any more presentation kinds of things or questions, maybe it's time to move to open mic.
Okay, this is Mike. I have a question or conversation with John about his PCB development concepts. When I do a PCB and start with a schematic and I start laying it out, I notice that a lot of times I notice that the wires get all crossed. So I'll go back to the schematic and uncross them, because assuming it's general GPIO, and to clean up the board. Do you do that, or?
Absolutely. I mean, what I normally do is, if I'm doing a board and I've got this, I've got, say, a microcontroller and I've got like a motor driver board, then I'm going to look at the pins on the motor driver board and look at the pins on the microcontroller, and I'm going to hook them up in the same order. Now, sometimes on the schematic, they come up upside down, but then it's just a question of rotating it or whatever. And sometimes, I go and reassign, change the order on the schematic so that they lay out better, because of course you want your traces, like if you look at let me share my screen again. If you look at my PCB design here, there's virtually, I think there's only one via for a trace where I have to cross this line right here. And that's it. The rest of them were, sometimes you can use tricks of how you lay them out. Like, for instance, these four here had to go to these three lines here had to go to these three pins down here. And if I ran them on the front side of the chip, they would all have to cross. So instead, I go down the middle on the back side, and then they don't have to cross. So you can also use tricks like that to change how you do layouts and stuff to make them. But like for the edge shut board, you know, these three are in the same order as these three, and I did that deliberately. You know, whereas my head I squared, or my LCD I squared C panel, which is, by the way, Tom, the same LCD panel you have on your development board. You know, I can't change where SCL and SDA are, and I can't change where they are on this connector. So, you know, this one goes down this way, and this one, instead of crossing it, just goes around behind it and comes up on the other side.
Have you or Don, or has anybody tried auto routers? Are those available in these hobby level things?
There is a some kind of an auto router in here and stuff that you can set up. I didn't generally make complex enough PCBs. I mean, some of my 4-layer PCBs where I'm actually putting an STM32 board chip on the board were complex enough that I probably could have used an auto router, but I don't make boards like that anymore. So,
in the distant past, I've used various PCB design tools, and I've used the auto routers and always been disappointed in their results. When I first started to design printed circuit boards with tape and vellum paper, double-sided, and you did all your own layouts, and you learn a lot about how to do layouts. And I was really disappointed with the auto routers. They didn't seem to do a good job at all, at least not a neat job.
Yeah, and that's the thing. I mean, I have my own rules about how I do auto routing. You know, I only use 45-degree angles. I never do 90-degree angles. I try and run the lines parallel and things like that, and stuff. And I try and minimize the number of vias that I use, and so on and so forth.
I started to work with KiCad 2 or 3 years ago, back when I got a desktop CNC machine and decided I wanted to try engraving my own printed circuit boards rather than chemically etching them. I found that KiCad was really easy to use, well, relatively easy to use. Learning curve wasn't bad at all. My goal was not to send Gerber files out to a PCB shop, but to convert into G-code so that I could run my CNC machine. And that worked well, although you end up with a substantial chain of tools in order to get to the point where you actually start cutting a printed circuit board. It worked, but I don't do it often enough that it's worth my while. If I made a board every 6 months, I would completely forget every time.
Yeah.
But I learned how to do it, and I had good results, so I'm happy.
Yeah, I should probably show you guys this tool that I use as well. Let me just start it here. I'm not running it right now. Oops. We often, like, I have a lot of projects on the go, you probably noticed. And I've been using hierarchical based text managers for a long time, and with just raw text. And the idea is, on the left side, you've got this hierarchy, and on the right side, you've got text, and each entry in here, you know, has children, but it can also have text. So I make a lot of notes about things that I'm working on. So for instance, this current balance robot that I'm working on right now, you know, that was the old one, and this is the new one, kind of thing. And so I make a lot of notes about, you know, how I'm going to use it with the URC and what the wiring's going to look like, and things about PID tuning and how to do motion. And when I designed this PCB, I did all of this work ahead of time to figure out, you know, what size it's going to be, what connectors, what components I have, how many pins each one has, you know, which pieces that I need, and things like that. You know, and things that I'm going to order from DigiKey as a result of this project, and you know, this is the camera that I decided that I'm going to use, and here's the pinout for it. So this particular one allows you to mix text and graphics in a really nice way, and you can make tables. You can do, there's all kinds of things. This is called Trillium, and it's a Linux only tool. Unfortunately for people who use Windows, but if you use Linux, you should definitely check it out. And it also, so I run, like right now I'm running on my desktop, and I also have a Linux laptop. And so what I've done is I actually have a, actually it's not running right now. I have a, because I can never remember the command line, but I actually run Trillium in a Docker. I had to reboot my image, my desktop, because something went funky. So now I'm running Trillium basically in a Docker image, and this client syncs to that. And so if I'm running here, I've got it, and if I'm running on my laptop, I can sync if I'm on the same network. And there's ways that you can host this Docker thing in the cloud if you want to be able to sync from wherever you are. I don't really care about doing that, but you can also do things like you can, on my laptop, I'm going to go away for a few days, and I can work on it and make changes and stuff. And then when I sync, it syncs back. When I get back to my home network, it syncs into this and basically stores all of this stuff on a database, in a database. So it's basically all of the, you can do nicely formatted markdown and just all kinds of ideas and pictures and to-do lists and whatever. So I find this really helps for keeping track of particular robots that I'm working on, the things that are involved in it, and how, like for instance here, I've got a Raspberry Pi Zero. So I constantly have to look at the pin up of the Raspberry Pi Zero when I'm looking for what pin is this or whatever. And, here's the spec list, and here's the dimension diagram for when I'm making a 3D printed mount for it or something like that. And, here's the ESP32 that I'm using, and URC information, and walking competition for Quick Trip and the rules and blah, blah, blah. So, just everything you can think of. I constantly am updating this document with stuff.
What's the name of the tool, John?
It's called Trillium, Trillium.
Thank you.
Yeah, that's the one.
I go
I'm
through all
looking
the
at-
same paradigms of trying to keep track of all this stuff. I
Yeah.
tend to use a very old-fashioned tool.
Yeah.
Yeah, and that's okay. When it gets to be too much, and this thing has there's search tools built into it, and you can make links and hyperlinks and within the documents themselves, also to outside websites, and you can embed pictures and just all kinds of stuff.
The Windows version of that thing is called Obsidian.
Well, Obsidian is a different tool. It's a tool that has similar capabilities to Trillium. The thing I like about Trillium is it's open source, so it's not run by a big company that's going to want money for it.
Well, it's free. If you want features, you need to pay for them. But the basic use of everything you described there, John, is free. And Obsidian, it works on your Windows, your Mac, all that kind of good stuff. The syncing is a bit wonky though, unless you pay for it. But yeah, same sort of stuff. It's a cool tool. It's a cool idea, a set of tools. I mean, a set of a type of tool, a mind mapping sort of thing. Is way cool.
Yeah. Yeah, and you can draw pictures. This thing has you can do Gantt charts and diagrams and state machine things. I mean, there's all kinds of capabilities that this thing has for different kinds of things, book templates, and there's so much.
If you guys are like me, just the simple act of forcing yourself to organize it and put it down on paper is almost as valuable as having the documents collected when you're done. 'Cause I find
Yeah.
just trying to get this stuff down on paper, it really helps straighten out my thinking to see what it looks like.
Yeah.
As I'm trying to move my thinking about what should go into a robot from my existing robot to one I'm going to build around Pico, I had to go through the exercise of doing exactly that for my old robot running an Arduino.
Mhm.
Curiously enough, when I did it, I found a number of flaws that I can now fix.
Yeah. Yeah, and like I said, I keep track of all of my robotics projects this way. It's a really useful tool for managing stuff.
It looks like I mean, aren't there wikis that do very similar capabilities?
Yes,
Yes, sort of, but not really. The real benefit of this tool is it allows you to manage your thoughts and you don't care where it's stored. In the wiki, you kind of care where it's stored. You kind of got to set up a link, but but in these sorts of tools, you say, I want this, that, and as you're typing, it goes, oh yeah, I remember you've got one of these things over here. You want to put a link in there for you as we go? The wiki doesn't tend to do that.
Yeah. The other issue with the wiki, of course, is unless you've got your own web server sitting on your home network, it's going to be hosted somewhere, and that hosting can, then you have to deal with security if you don't want everybody in the world being able to access this or edit it or whatever, and you have to worry about whether that wiki is going to go away at some point or that sort of thing. This tool, Trillium, like I said, it saves the data in a relational database that's on my machine here, and I can export. It backs it up, and it's just a relational database, and I can export all of this data as HTML or Markdown or whatever. So a web browser will never go away. So even if this tool, they stop supporting it or whatever, I can still keep on using it, the version that I have, and it works really well. So it's really about, where do you want your data stored? And I want my data stored for this stuff. I want my data stored locally. I don't want it in the cloud. I don't mind it being like in Dropbox or something like that where I control it, but I don't want it out on somebody else's server, some company that may decide, you know what, we're going to change our policy. That used to be free, but it's not going to be free anymore. Or, because we've seen that with CAD packages and with PCB stuff. Eagle used to be completely free, and Fusion and all of these things have had free versions in the past that have migrated into pay versions, or greatly reduced the functionality of the free versions and things like that. It happens all the time. Oh, I didn't know Trillium was supported on Windows. That must be something relatively new. That's cool.
Wow.
Oh yeah, and Mac too. Wow. Okay. Yeah, and like I said, the thing I like about Trillium is it's the same reason I like KiCad. It's open source, so it's not likely to go away. If the author decides to stop working on it, it might stagnate. But the functionality that it has right now is perfectly adequate as far as I'm concerned. Especially given the sync capabilities between multiple machines. You can embed PDF documents in here too. So, and I mean, all of this information, especially the sort of the public reference information like Raspberry Pi, you can go and look it up, and do a search and find it all again every time. But it's nice to have it in one place, and especially if you're offline somewhere where you don't have Starlink with you or whatever, but you've got your laptop, you can still work on this.
You can do, well, what I use, I'm not the biggest user of Obsidian, but with tools like this, what you can do is, and what I find interesting is that you can have, let's say you have 27 projects open, 27 different things you're doing. And each one of them, you may have a page on that thing that has a to-do list on it. Like, I got this to do and that to do and this to do, and you can check it off. You can do all these things. And so what I do with mine, I have a daily rundown sheet where I go through there and I said, anything that's marked as a client to do in my daily rundown, put in this section. Anything that's marked in all my other, put in this section. So literally I can have one page that has every to-do thing I care about it, no matter where it is inside the entire application. It's really pretty cool. And John, if you've already said that, because I didn't catch everything you said, I'm sorry if I repeated myself.
No, that's a perfectly reasonable use. I'm pretty sure Trillium can do that sort of thing too. I mean, Trillium, you can actually write code to implement features and stuff. So if it doesn't do something,
they have their own little scripting engine to do all of this kind of thing. If you want to get into it and do all kinds of stuff, you can. And it's pretty cool. And you're not worried about the underlying infrastructure, just like John said. That's all handled. That's being extracted away for you. So you don't need to. If you really want to deal with it and get into it, you can. But you don't have to, and you get all this fun stuff to go do. It's pretty cool.
Yeah. Yeah, I have an old one called Vault that I've used for like literally decades, but it's only text. It didn't support anything other than text. And eventually I wanted to start putting in pictures and links and tables and the kind of nice formatting that we've come to expect in things. So I did a lot of research and looking and whatever, and my brother pointed out Trillium as a really good Linux capable package. So
any of y'all remember HyperCard from way back in the day?
Yep. This is like HyperCard but better.
Not only do I remember it, I saw it this last weekend at the Vintage Computer Festival. There was lots of Lisas and HyperCards and all kinds of stuff like that going on.
Yeah. For me, the most important functionality is the 2-pane functionality, where on the left you have your hierarchical list, and on your right you have the data for the particular entry that you've selected. That's the most important thing, because I don't want to look at it. It's like source code. I don't want to look at the entire program all at once. I want to see the piece that I'm interested in right here and nothing else. So having that capability is really important.
My partner does something like that with Google Docs, but it's such a kludge compared to what you're showing in Trillium.
Yeah, I started using Google Docs before I found Trillium because I really wanted the capability of switching between my laptop and my desktop, and I've been using Dropbox for that, but it's like I said, I couldn't get graphics in and stuff like that, and I started using Google Docs for a few months, and then found Trillium, and it's like, wow, this is so much better.
It's orders of magnitude better.
But the shareability is an issue.
Yeah, it doesn't have shareability like Google Docs, but I don't really care that much because this is I don't work on public projects, so this is all my stuff. If I'm going to work on public projects, we'll use Google Docs or something like that. But for my stuff, this is what I want.
What do you think about the lack of cell phone integrations?
So they have, so like I'm running this on Docker, right? And you can access, there's an HTML version of this available. So this Docker image that I'm running, that's running the Trillium backend, basically the Trillium server, that can present in 2 different forms. You can run it in a client, like the dedicated client, or you can run it on a web page. So I can actually just pop open a tab in Chrome here and type in, 127.0.0.1 with that port, and boom, up comes the same thing on a web page. And you can do that on your phone as well. Now, of course, if you're not at home with your phone, then you have to do the whole reverse DNS lookup pipeline to your thing, whatever stuff. But it can do that. And, you know, I mean, you can do limited editing on your phone, but I mean, you know, phone's not really useful for doing that sort of stuff anyway. But you can certainly look at your pages and things using the web interface.
And I found it interesting that the application is named after the provincial flower of Ontario.
Well,
The
that one has,
developer was living in Ontario when he started to work on it.
the one has 2 L's, and this one only has 1 L. So that's the difference. It took me a while to figure out that, oh yeah, that's only 1 L, even though they actually use the flower as the icon, or at least something that looks like the flower. But yeah, and you can also set up like protected areas where you have a particular like part of a particular section of the tree that's password protected, and stuff like that. So, you know, if you have private information about banking or whatever stuff that you also want to keep in here, you can put it in one of those areas. But yeah, I've been organizing my robotics projects this way for 20 years, using various information managers, and I've tried lots. I've tried Evernote and a bunch of other ones like that, and I've never been happy with any of them until I found Trillium.
I'm once removed from Tom's approach here. This is you know, one of many notebooks with, you know, chicken scratch on it, that, you know, pinouts and colors of wires and, you know, stuff like that.
I use Joplin Notes. It's another application that's available for Linux and Windows and all sorts of stuff, and it's done in Markdown. And
yeah, so is Trillium. Trillium is all Markdown.
well, I've used that for, I use it for work actually, because I'm old and forgetful, and that's why I write a lot of notes about what I do during the day, so I can look it up again. And I do that by project. So I give it a tag with a project name, and I can search that project and find whatever. So I've used that. I find that sometimes attaching pictures is a little cumbersome.
Really? Huh, that's interesting. I'll show you how. I'll show you how we do it in Trillium. It's really simple.
Yeah.
So I'll go to my Balance Droid version 3, because this is supposed to have a picture right here. And I'm going to click. So this thing here is the thing that allows you to choose like the style of the paragraph and formatting and stuff. But one of the things you can do is you can upload an image from the computer. So I can go to my downloads folder, and actually I think it's in pictures. You know what? I don't have a recent version of that. So let me just go over to, well, here, I'll just do an example of an older one just to show. So in pictures, we'll just pick this one for now. So then it shows up here, and you can resize it to be whatever size you want. You can change it so that it's left justified or center justified, or, you know, have the text wrap around beside it or not. You know, different options. You can automatically set different sizes. You can add a caption if you want, stuff like that. So it's really easy to add pictures with this.
Yeah, it's a much more graphical way to do it than I'm using with the Joplin Notes.
Yeah.
So it's not quite as easy, and you create links, and then link to the picture in a folder somewhere, and so
yeah,
seems much nicer.
Yeah, and you can, I mean, you have basic properties here. There's lots of different kinds of things. So relation maps and canvases and mermaids and books and code. It's got pretty printer for all kinds of different codes. If you want to actually paste some code in, it'll pretty print, whatever syntax you have. Protected, bookmark it. There's all kinds of stuff you can do with this.
Well, looks interesting. I think I'm going to give it a try.
I've been very happy with it. It's sometimes the sync is a little funky in that I have to, like, I'm running a Docker image on my desktop, and I run the client on my desktop, and I run a client on my laptop. And sometimes when I make changes in one place, I sync it to the database, but they don't show up in the other client until I close it and start it back up again. But, the nice thing about it is, of course, you don't have to save or anything like that, because it's automatically syncing to the database. And this little button here allows you to force a sync if you want. And you can also have multiple tabs. So if you want, to be switching back and forth between different places in the document, stuff like that, that's convenient as well.
Yeah, that's one thing that Joplin Notes does not do well, is having the database open up on multiple clients.
Yeah,
it tends to error out, and then it's a nightmare.
Yeah. Well, like I said, the back end to this is a SQL database, and it handles all of that stuff quite nicely.
That's one thing Microsoft OneNote does pretty well, but and it supports hierarchy, but it's nowhere near as clean looking and capable as what you're showing in Trillium.
Yeah.
But its sync is fantastic. You can easily, with OneNote, easily add stuff by phone or by laptop, and it just magically appears wherever.
The problem with OneNote is your data is in Microsoft's cloud.
Oh yeah. No, that all true. All true.
That's why I didn't want to use something like that, and why I won't use Evernote and things like that. I mean, aside from the fact that their functionality isn't as good, from a fundamental premise, I want my data on my machine for this stuff. Just because, I don't want it to go away.
Yeah.
And I don't want to have to constantly be backing it up and whatever in case they decide to take it away. Like Google does that all the time. You set up all these complex things with their apps, and then they just, we're not going to support that anymore. So,
John, can you use like a cloud storage location?
You can, absolutely. They have, if you go to trillium.io, they actually sell for a couple bucks a month or whatever, a few bucks a month. You can host your Trillium database on their cloud, and then you can access it from literally anywhere.
Okay. Do you know if I can sync it to let's say Nextcloud?
You can put it wherever you like. If you can install Docker, like if you can run it as, there's a whole set of instructions for how to set up servers in different environments.
Okay.
So it's inherently a client server system, so you can put server wherever you want. I just happen to run it on this machine because this is my Linux desktop and it's always running, and I very rarely reboot it. So it's just there.
Yeah, if we finish Trillium, I've got a question for you guys. Do any of you know anything about what robot overlord is?
Yeah, it's
Yes,
it's a guy who's building basically something like ROS for legged and multi-jointed robot arms and stuff, effectively.
Well, so in I talked to him, or I said, it's like thought, well, that might be an interesting interesting monthly talk topic. And he called it on his website. He calls it a simulator, and he has all these examples, as far as I could tell, of you set up some data structure that has the definition of your robot, and then you give it some instructions. But I couldn't see that it was the kind of simulator that I'm familiar with, which operates in time steps. That's why I was like wondering if you guys know anything about it, like what it actually does, how you use it, what you use it for, whether it's interesting for this group.
I know that he actually builds and sells modular components for building robot arms, like individual joints and pieces that you can put together in different orientations and stuff for building basically whatever kind of robot arm you want, multi-axis type stuff. And his, Robot Overlord, it can simulate it, but it can also run it in the real world at the same time, kind of thing. So in parallel. And so you can use the simulator to try and, work out what you want to do and then run it in the real world and see how close the simulator is.
Well, he calls it a simulator on his website, and to me, a simulator is something that you apply stimulus to. For example, you apply a force to some joint, and you expect something in it to move, and you have feedback back out of the simulator. And so you wrap your code, maybe you'd say you wrap the simulator around your code, and your code sticks commands into the simulator. The simulator causes joints or objects to move, and
Give him a minute here.
this was that. Do you guys think this is that?
From my perspective, it's more of a visualization tool than a simulator. I don't know how much actual simulation there is in it, but it's a visualizer to visualize how the robot arm moves and can interact with. I don't know how much interaction there is with things, or whether it's all just visual. I'm not really interested in robot arms very much, so I didn't look into it too deeply.
The more I read, the more I came to think that it was, as you say, a visualizer, something like RViz.
I downloaded it and installed it at his suggestion a few years back, and started to play with it, and rapidly got lost because it wasn't anything like, as you say, Paul, it wasn't anything like what I was expecting. And I suspect you need a substantial ability to design structures and paths and navigation in mathematical terms rather than visual or graphical terms in order to get any benefit out of it. I rapidly got lost and couldn't find any documentation to help me with it. So I abandoned it. I still have it running on my machine. I just called it up. It still runs, but it doesn't do anything for me.
Okay.
He's a nice guy and he's a smart guy, but it's hard to understand how to use the tool he developed.
Thanks. Thanks. I was worried that I failed to understand something basic about it, but you guys have kind of
he's a member of the Vancouver Club, and he demonstrates a lot using that tool, because what he's doing is doing advanced development on the software and hardware designs of the robot arms, as John described. He clearly understands his tool very, very well. But how you make it do the things he can make it do escapes me. I know he writes a lot of code behind the scenes in order to implement the things he demonstrates. John, any other thoughts? You've seen some of his demos?
Yeah, I've seen a bunch of his demos and stuff. Like I said, I'm not really into robot arms, so I don't really care that much.
Yeah.
You know, it's. I can see where a tool like that would be useful if, you know, you're building modular arms and you want to have different capabilities and try things out and whatever. But I'm not sure. It has the same problem that regular robot simulations have, is that, you know, it's great in a simulator if you don't have a real robot, but as soon as you have a real robot, I don't see the point, because 90% of what you do in a simulator doesn't work in the real world. You know, because the simulators are never that good. And, you know, and the sensors in the real world are never that good, and the motors are never that good, and so on and so forth. And I'm sure that, you know, if you're willing to spend hundreds of thousands of dollars on hardware, then you can probably get stuff that's good enough that the simulator might actually be useful. But from my perspective, I don't find them very useful for anything.
Hence the behind the scenes work that it was apparent he was always doing for any of his demonstrations, to build the mathematical model embedded in the code that was used to implement some component he had added to his simulation. A lot of work there.
Okay, thanks, guys.
40. Yeah, and it's all written in Java and runs on anything. So.
Well, I'm hearing a pause. Is it time we round it up for the night?
Probably.
All right. Well, thank you, everyone. Interesting meeting, interesting discussions, and see you all maybe next Tuesday, or maybe not. Depends
Hopefully
on-
Saturday.
Saturday.
On
yes.
Saturday, definitely.
Yeah.
And same Google Meet meeting ID as this meeting. All right.
Same
Good night.
bat channel,
Good
bat
night.
time.
Cool.
Night all.
See ya.
No.
I guess we have to stop the recording.